in fact, there's one more example of a normal subgroup that I wanted to tell you about briefly. So here it is. So let's phrase it as a proposition. So let G be a group and H be an abelian group. Then the subgroup of the form H cross the identity in G, which is the same as simply H comma identity in G, where H is in H. We already seen such things. You know these are subgroups. So then this is a normal subgroup of H cross G. We already know that these kinds of things are subgroups. When I just put identity in one coordinate, then I actually get a subgroup. But this is also telling you now that this is actually a normal subgroup. So let's prove this. So I want an arbitrary element of A cross G, but an arbitrary element of A cross G looks like little h comma little g. So let H be in H, G in G. Then I'm going to look at the left coset of HG with respect to this group. So what is it? So this is again HG, and so right now maybe I will not use this H here. It's called H prime, e.g., where H prime is in H, right? This is just that. So how do you multiply an element by a coset? So you get now H prime G, because G times the identity is just G, where H prime is in H. Okay, but now I can use the fact that H is abelian, so I can switch H prime and H. So this is equal to H prime H G, as H prime is in H, which gives me H prime identity as H prime is in H times the element H G. Okay, which is nothing else but the right coset. All right, so this proves that that is a normal subgroup. So just one example maybe. Z cross the trivial permutation is a normal subgroup of Z cross S3. Now you see, Z cross S3 is not an abelian group, but it has this abelian direct factor, namely Z, and therefore essentially just if I just place the identity on the S3, then the S3 doesn't really interfere with the multiplication here. So any such group actually will give you a normal subgroup. But this isn't, I mean, it's a good source of normal subgroups. However, it's again, we're sort of using the fact that we have an abelian group here.